Hello, hello, good morning, good afternoon, good evening, wherever you are, whenever you are. I wanted to talk a little bit about modeling with polynomial functions. There's really two topics in this section that I want to talk to you about. Okay, so the first thing is how to write an equation given either a set of points or an actual graph. We're not going to do the graph because my drawings are not phenomenal. We're just going to assume that we've already gotten the graph and take the points from the graph. And then the other piece that we're going to talk about is the finite differences. Okay, so without further ado, let's say this is example one. We are going to find the equation of a cubic function. Okay, and so when we have a cubic function, we need at least 4 points for us to know what that cubic function is going to look like. So let's assume that we've already pulled these points from, from the graph. And I'm going to take a look at my notes in here just to make sure I have everything that I want to talk about. Okay. So if I'm not looking at you, you know why. All right. So we have a few different things in here to unpack. So the first thing that we want to pay attention to is that this is the y-intercept. This is the only one that has a 0 in the x column, in the x place value, right? And then the rest of them are all x-intercepts. That's an x-intercept, x-intercept, and x-intercept. So one thing that we know about x-intercepts is that whenever we have something that we have to factor, right? We are always looking for the zeros. What are those zeros? What do those zeros mean? Those zeros actually mean that we're looking for when our graph hits the x-axis. That's why they're the x zeros. And that's something that you covered in Algebra 1 or in a previous section altogether. Okay, so one thing that I know is when I go ahead and I take a look at these 3 points, I know that this is saying x equals -4, x equals 2, and x equals 5. Now, in order to take this from a fully factored position where my graph is, where my polynomial function is fully factored, to a slightly less factored function, I actually need to say that this is x plus 4. Right? Because if I have x plus 4 equals 0, then I know I can subtract 4 from both sides to get this particular answer right here. Okay, so then I'm going to say x minus 2 is another one. And then I'm going to say x minus 5 is another one. Now, realistically, I don't need that equals 0 piece because it's not valuable. It was just valuable to explain it. So those are for sure 3 things that I'm going to multiply in order to get my polynomial function. Now, if you notice, I have 3 x's. Those 3 x's means I'm going to have a cubic function, right? X to the 3rd, right? When I multiply them out is going to be a cubic function. So that's one thing that I know from these points, okay? The other piece that I know is we need to know how it like moves, right? Because cubic functions sometimes can move like this, sometimes can move like this, right? Sometimes they can even move like crazy pants like that, right? And we want to know what it moves like, right? So without the actual graph, we can't tell, but we know that at a certain point it stretches and shrinks a little bit, right? So there's that A piece. That A piece is what's going to tell us how much we're shrinking, how much we're stretching, how much we are actually, if it's a negative number, are we going to flip it in some way or another, okay? So realistically, so far what I have is my f of x, my function, equals my a, some sort of stretch or shrink, I don't know what that is just yet, times this x plus 4, x minus 2, and x minus 5, okay? So that's what that gives me so far. Now, what I really need to do is find this variable because I don't like having equations with 2 variables that are 2 unknowns. So I need to solve for this a. In order for me to be able to solve for this a, I actually need to take this point right here and make it be a part of this particular equation, kind of like how I solved for y equals mx plus b. Sometimes when I wasn't given the y-intercept, but I was given 2 points, and then like you solve for the b, right? So in this case, what I'm going to do is I'm going to say, okay, well, I know that every point is actually x, y. or it's x and then f of x, right? So if my point of 0, 10 is the point that I'm going to choose, because that gives me an actual point for y, I'm going to do that. I'm going to replace this piece with 10. This is going to stay a, because that's what I'm looking for. That's what I don't know yet. And then all of my x's are going to be replaced with that 0. So I'm going to have 0 plus 4. I'm going to have 0, whoops, minus 2. And then I'm going to have 0 minus 5, right? So now let's go ahead, let's combine like terms. Let's solve for a, because now a is the only variable we have. Okay, so I'm going to have 10 equals a times 4 times -2 and times -5. These two I know is going to be positive 10. Positive 10 times 4 times a equals 10. So it's going to be 10 equals 40 a, and then divide by 4. Oh gosh, 40. And so then a is going to be 1/4. Okay. So now we have one final step to really bring everything all together. So realistically speaking, we're going to take this equation right here, and we are going to replace it with this a equals 1/4. Okay. So my function of x is going to be 1/4 times x plus 4 times x minus 2 times x minus 5. And this is my equation for the polynomial function, or my function for my polynomial function, given these 4 points right here up top in this equation. Okay. Now, if you still need a little bit of help, if you're having a little bit of more trouble, absolutely go ahead, pause the video, rewind it, backtrack, whatever it is, and then reach out to me if you need help. I'm always here. Okay. So example 2 is going to talk about finite differences. Now, I do not have a graphing calculator. However, basically what we are doing with finite differences is we're looking at a table of values or at a slew of points. And the slew of points should be converted into a table of values. And we're trying to figure out what our polynomial function is using a graphing calculator. Okay. So I can help you out up until you get to the graphing calculator, and then you'll have to take it from there by putting in lines of regression, okay? So basically what this is saying, what these finite differences are saying is as follows. All right. A finite difference is when I find various differences, the level of differences is actually my highest degree in the polynomial function. Okay, that's all that means. So let's take a look at an example. Let's see how that all plays out. Okay. So usually I have an x and an f of x, okay? And let's call these my points. Whoops. Okay. And then I'm going to have my f of x as these points right here. Now you'll notice that they could go from positive to negative, from negative to positive. They could constantly change, or they can just change a couple of times and then we're done. And that's just because this is one of those graphs that probably looks like this. We're going to go down, then back up, then down, then back up, right? So it's just a way, it's just showing the way that the graph looks. Okay. So here's what we're going to do. We are going to take a look at level 1. Our level 1 is a level 1 of differences. So I'm going to find the differences between each of these two numbers. Okay, so to go from -2 to 15, how many jumps do I need to make on the number line? 17, right? Then to go from 15 to -4 is -19. then I have 53, and I know all of these, not because I'm so brilliant, it's because I did them a little while ago. Okay, so that's our level 1. If all of those numbers would be the same, that means my function would be y equals mx plus b in that format, where x would be to the first power, okay? They're not all the same, so we need to move on to level 2, okay? So let's find the differences between level 2, okay? So now in this case, we're gonna go, it's negative 36, 72, 180, and then 288. Now again, they're not the same. If they were the same, let's say we would constantly subtract 36. That means my function, my polynomial function, would be x to the second power. Since they're not yet all the same, we need to keep going. We need to take it to the next level, okay? Let me get a green in here. All right, so now we're at level 3. If these would be all the same, which I know they are, but let's take a look at what's going to happen here. How the difference of all of these is actually all the same. So this is going to be 108, the difference between these two. This is also 108, and this is also 108. So now when I look at these three and I say, oh my, look at this, they're all the same difference, I know that my polynomial function, whatever that function may be, it's going to start with f of x equals ax to the third plus bx squared plus cx plus d. It's going to have this format right here. Okay, now A and C and B and D and whatever, all of those could be 0 values, could be non-zero values. So long as my exponent, my degree, my highest exponent is actually 3. Okay, so from this point, this is all you're doing on paper. From this point, you are now using your graphing calculator to determine what your function is going to look like. In this case, when you plop all of these pieces of information in, you're going to get something that looks like 1/2 x to the third minus 1/4 x squared plus 1/8, like whatever, like crazy pants numbers. This is not a function that you can create, that you can find on your own, okay? You're actually going to need to use a graphing calculator. So the only time that this is going to be valuable is when you absolutely can't use this method of finding an equation. Okay, so I hope that was helpful, and I will see you next time. Bye.